Welcome back to Decoding the Digital Lab with CSols, the podcast that offers strategies and valuable insights on emerging LIMS and ELN technologies. I'm your host, Megan Pettyjohn, and in this series, we're exploring new ideas and advancements in the lab. And today, we're exploring AI in the lab, but breaking it down for beginners. With me today is Alec Edgar, a lab informatics consultant who's navigated the new and exciting world of AI in the laboratory. Hi, Alec. Thanks for joining me today.
Hey, Megan. Thanks for having me. It's a pleasure to be here. There's so much happening in the AI space, especially how AI is evolving in the lab. And I'm really excited to start unpacking where the industry's headed.
Yeah, it feels like the potential of AI to revolutionize scientific work is immense. But there's also a lot of buzz and maybe even some confusion around what it really means for day to day lab operations. So, I would like to start with the basics for everyone and lay some groundwork around AI. So, Alec, in your experience, what does AI actually look like in the laboratory setting? What are some concrete examples of how it's being used?
When we talk about AI in the lab, it's not about anything like sentient robots taking over, although there's some robotic automation being used in laboratories. Instead, it's really about intelligent software tools that are going to augment and are augmenting human capabilities. For instance, let's consider intelligent alerts. There are AI systems that can monitor instrument data in real time and flag anomalies or potential issues before they escalate. This is really an effective time saving and error prevention method. We're also seeing more predictive modeling where AI actually analyzes historical data to forecast things like potential upcoming instrument maintenance needs or even the likelihood of certain experimental outcomes, both of which help labs plan more effectively and operate more efficiently.
So, AI is about extracting richer, more timely insights from the vast amount of data labs generate. I'm sure that is fundamentally changing how labs interact with their data, allowing them to gain a deeper understanding of their samples and processes.
Yeah, AI is also powering smarter search and reporting. Imagine being able to ask your LIMS or ELN even a question in plain language. We call this a natural language query. For instance, you could ask, show me all the QC results across all batches for some products from the last month that were outside of specification. AI can now actually understand that and pull the relevant data much faster than traditional methods where you need someone to develop SQL statements or scripts or have some other technical background. And really, when it comes to reporting, AI can automate the generation of summaries, identify key trends, even help visualize complex data sets.
It definitely sounds like it could free up a lot of scientists' time. Now, with all of this potential, there are bound to be some misunderstandings. What are some common misconceptions or assumptions that you encounter when talking to labs about AI?
Yeah, there are definitely several. I think one of the big ones is the sort of myth of AI being plug and play.
Mhm.
Uh, Sometimes people think you can just buy an AI software, install it, it's going to magically solve all of your problems. In reality, successful AI implementation requires significant integration efforts with existing systems like LIMS, BLN, or other systems, as well as careful data preparation, and that will ensure quality. Also, ongoing maintenance and fine tuning. It's really not a simple out of the box solution like people might think.
Yeah, that makes perfect sense. AI is only as good as the information you put into it.
Yeah, exactly. And that really leads to another misconception, which is data independence. Some people assume that AI can work wonders with any data, regardless of its quality, its structure, how complete it is. But the truth is, the performance of any AI model is heavily reliant on high quality, well harmonized data. And if your input is messy or inconsistent, the AI output is going to be unreliable at best.
And I know one big question on a lot of people's minds is, will AI replace human lab professionals? What's your take on that?
Yeah, I think that's a really important question. The overwhelming consensus in the field is that AI is far more likely to really just augment rather than replace human lab professionals. If you think about it, AI can handle those repetitive, time consuming tasks like data entry or initial image analysis, freeing up highly skilled scientists to focus on more complex experimental design, critical thinking, interpretation of results. That human oversight and expertise is going to remain absolutely crucial, especially in areas requiring nuanced judgment and ethical considerations.
I'm glad you brought that up. AI, despite its power, fundamentally lacks human attributes like consciousness, empathy, intuition, and moral compass. So, human oversight will always be needed. Are there any other common misconceptions?
Yeah, I think another one is the idea of AI as a universal solution. Some people might assume that it can solve any problem in the lab, regardless of the specific context or if there's even enough relevant data to train the model efficiently. And the truth is, AI is really best applied to well defined tasks where there's a sufficient amount of good quality data available.
True. We run into this situation when using generative AI. Asking a single prompt won't provide the full desired answer. Additional prompts are always needed to perfect the final output. Have you heard about the magic black box idea?
Yeah, some users might treat AI as a black box and really that it just spits out answers without needing to understand its limitations, its potential biases, or even how it arrived at a conclusion. And that lack of understanding can lead to a lack of trust or even worse, inappropriate reliance on AI's outputs without true critical evaluation.
Which ties into the assumption of inherent objectivity.
Exactly. Yeah. There's a false assumption that AI is inherently objective and unbiased, but in reality, AI models learn from the data they're trained on. And if that data reflects any existing biases, for example, in patient demographics or diagnostic AI, then AI can perpetuate or even amplify those biases, which leads to unfair, inaccurate results. And one real world example of this is in dermatology, where AI tools designed to detect skin cancer have been trained overwhelmingly on images of lighter skin. And there's a scary result to this. These AI systems can be significantly less accurate at identifying cancerous lesions on darker skin tones. And this really isn't a theoretical problem. It means that these tools, which are supposed to help, could actually perpetuate already existing health disparities by missing or delaying crucial diagnoses for people with darker skin, all because the initial data didn't properly include all of the relevant data sets.
What about the assumption that AI is constantly improving on its own? I admit I am one of those people that had thought that at one point as well.
Yeah, the concept of self learning perfection is a total misconception. While AI models do learn and improve over time with more data, they don't, and as of today, can't reach a state of perfect autonomy in the lab setting. And they can actually cause themselves to be more difficult, more incorrect in the data that they are creating. Most AI in the labs require ongoing monitoring, retraining with new data, fine tuning by human experts. And you have to keep in mind how much data is actually being generated in a lab setting. It's constantly growing and evolving. So to maintain accuracy and adapt the AI model to new conditions or new standards, it takes ongoing maintenance, which, by the way, often comes with unknown future costs that labs have to factor into their long-term budgets.
You also mentioned unknown future costs with the use of AI. What does that look like? Can you tell us more about that?
Yeah, sure, absolutely. Imagine a lab deploying an AI model that works well initially, but wasn't built with reproducibility, clear retraining mechanisms, or comprehensive documentation. That lab essentially incurs unknown technical debt. When new imaging standards emerge or the lab needs to classify new disease types, adapting that initial AI system will likely require significantly more time, effort, cost than if it had been designed with these future needs in mind from the start.
Okay, so we've covered what AI is and cleared up some common misconceptions and misunderstandings. Now let's talk about the why. Why use AI? What are the key benefits to make embracing AI so compelling for laboratories?
Yeah, well, the potential benefits are really substantial. We're talking about significant efficiency gains through the automation of repetitive non-physical tasks, leading to faster turnaround times and greater throughput. AI can also improve accuracy by reducing human error in data entry and analysis. We've already touched on automation, but it's worth reiterating how much time and resources can be saved. And AI excels at complex data analysis, identifying subtle patterns and insights that could be missed by humans. Ultimately, all of these factors can contribute to significant cost reduction in the long run.
Can you give us a few examples of how AI improves the speed and accuracy of lab work?
Yeah, sure. Imagine a large reference laboratory that processes thousands of tissue biopsies in a week. Before AI, each slide required a meticulous manual screening, but with an AI system integrated into their digital pathology workflow, there's several benefits that emerge. The first one is, slides are now digitized, which allows for image analysis as well as reduced physical storage space requirements. The AI can then pre-screen these digital images. It'll flag suspicious areas, categorizing normal cases with high confidence, which might then require only a rapid confirmation by a pathologist and quantifying biomarkers. And third, pathologists receive these pre-analyzed cases so they can quickly confirm AI findings for straightforward cases or dedicate more time to those AI flagged complex or borderline ones.
That's a great example of how AI benefits the lab. What about the technology benefits? How is AI helping us to achieve a digital transformation in the lab?
Yeah, AI is really that next evolution in digital transformation. We've spent the last 2 decades or so working to transition laboratories from a paper based state to a digital state. And with the advent of AI, we're now transitioning into an intelligently automated digital state. And this is where industry can begin truly leveraging the decades of data that they've been collecting using LIMS or ELN.
This is what we've been helping labs do for years to transition from paper based systems to computer based. It will help businesses stay competitive. And now, if they are digital, they are just one step closer to implementing AI strategies.
Yeah, exactly. And we're seeing some exciting applications across various lab types and functions for companies that are already truly digital. In reporting, AI can automate the generation of routine reports, summarize key findings from large data sets, even create interactive dashboards for better data visualization. And for data cleanup and harmonization, AI can really play a crucial role in identifying inconsistencies, standardizing formats, enriching metadata. All of that is really leading to higher quality and more usable data.
And what about specific lab types?
Yeah, well, in contract labs, for an example, AI can help optimize resource allocation, predict turnaround times more accurately for clients, and even automate the generation of client specific reports, which tend to be hugely time consuming. In manufacturing, AI is being used for real time quality control, predictive maintenance on equipment, optimization of production processes. And on the clinical side, we've spoke a little bit about the digital pathology workflow, but AI is also assisting with diagnostics in other ways, analyzing medical images and accelerating drug discovery research.
So, for labs looking to get started with AI, how does it actually integrate with existing systems like LIMS or ELN? That seems to be the critical piece of the puzzle.
Yeah, Megan, you're right. And seamless integration is definitely key. The focus needs to be on ensuring smooth data flow between AI tools and your core informatics systems. And this often involves leveraging workflow integration capabilities within the AI software or utilizing API connections of different types to allow different systems to communicate effectively. The goal here is really to make sure that the insights generated by AI can be easily accessed and acted upon within the lab's existing digital infrastructure.
Looking ahead, what are some of the future predictions you have for the role of AI in the lab over the next couple of years?
Yeah, I think we'll see even more sophisticated AI powered analytics embedded probably directly within LIMS and ELM platforms. That's really going to make advanced insights more accessible to everyday users. We'll likely see more widespread adoption of AI for predictive maintenance and lab automation, so further increasing efficiency. Uh, Personally, I'd really like to see an improvement of scheduling and management of resource allocations from people all the way to equipment. And I also anticipate advancements in explainable AI, which actually takes the time to show and explain how conclusions are derived. And that makes it easier to understand and trust the decisions that are made by these systems. And that's really going to be crucial for regulatory acceptance.
That's a fascinating glimpse into the future. Alec, as our expert today, what's one key tip or piece of advice you'd offer our listeners who are looking to excel with their AI implementation in the lab?
Yeah, my biggest piece of advice by far is to start with a clear problem statement that you're trying to solve. Don't just implement AI for the sake of it. Take the time to identify a specific, well defined challenge in your lab where AI has the potential to provide a tangible solution. By focusing efforts, you're going to have a much higher chance of success and be able to demonstrate the real value of AI to the broader organization.
That is excellent practical advice. Alec, thank you so much for sharing your expertise with us today on decoding the digital lab. It's been incredibly insightful.
My pleasure, Megan. It is, and it's going to continue to be an exciting journey in the world of AI. And I encourage everyone to explore those possibilities of AI within their labs.
Well, that's all the time we have for today's episode. If you like this topic and want to hear more industry trends, be sure to subscribe to our podcast. We also have a newsletter that highlights current events on a weekly basis, which you can sign up using the link below on the screen at info.csolsinc.com/subscribe to newsletter. And catch you next time.